Go. Hello and welcome back to Calculus 1 section 4. Hello and welcome back to Calculus 1 section 3.4 on product and quotient rule. That's how it's done. So we have now two formulas that will deal with the product and the quotient of two functions, and they are special formulas which you need to memorize, obviously. The first one is the product rule, which is the derivative of f times g, right? So you have two different functions, let's say x squared times e to the x. So this one is going to be f times the derivative of g plus g times the derivative of f. And there is a proof and derivation and all of that, but we don't do that in this particular class. So you'll have to trust me on this one, right? There is a way to write this in a more compact form where people usually use u and v because it's faster to write. So the alternative form, I'll just put the alt over here, is going to be u times v, the derivative, is uv prime plus vu prime. It's the same thing as up there, just compact. And I can just say where u equals f of x and v equals g of x. So it's just faster way. Now, generally, I remember things like visually and so on because I'm a visual learner. But for whatever reason, I remember this formula through words. I don't know why. So, and to this day, anytime I see a product rule, immediately in my head goes, copy the first derivative of the second plus the second times derivative of the first. Because you have the first and the second function, right? First is f, second one is g. So copy the first derivative of the second plus copy the second derivative of the first. I don't know why I remembered it like that, but I did. This is the only formula which I remembered in that way. So that's the fun fact of the day. All right. So we can now take derivatives of, as I said, x squared, let's say e to the 3x. So you have the multiplication. Here I'll put the multiplication in blood. There we go. So you see that you have the function f, which is the x squared, and the function g, which is e to the 3x. And all you need to do is to unleash the formula. Copy the first, well, that's x squared, times the derivative of the second, well, that's 3e to the 3x. We know that when you take the derivative of e, that number drops in front. Plus copy the second, well, that's just e to the 3x. This time you don't get the 3 in front because you're not taking the derivative. Plus the derivative, times the derivative of the first, well, that's 2x. So here we have f times g prime plus g times f prime. And you see that the formula is satisfied. Copy the first, derivative of the second, plus copy the second times derivative of the first. Now, we are not done because some of you are computer science majors. And chapter 4 is also coming up. So those are the two reasons why we are not done. You have to factor every time. Make sure you factor and simplify as much as possible. In this case, you can kick out x e to the 3x. What's left from the first one is 3x. And what's left from the second one is 2. And the reason why you have to factor is because in chapter 4, you go equal to 0 and then solve the equation and then do the rest of the problem. So in chapter 4, this thing will be something that you just write down quickly. and then you set it equal to 0 to solve the equation, get critical points, and then do the rest of the problem. So practice now to simplify and to factor and all of that good stuff. The derivative of 3x squared plus x minus 1 times the derivative of ln. So 3x squared plus x minus 1 times ln x. Copy the first, derivative of the second, plus, go on, you got this. All right, so the first one is f, the second one is g. Copy the first. 3x squared plus x minus 1. Derivative of the second is 1 over x. That's what we learned for the derivative of ln x. Plus, copy the second. That's ln x times the derivative of the first is 6x plus 1. Right? Derivative of the polynomial, 2 times 3 is 6. So 6x plus derivative of x is 1, and derivative of negative 1 is 0. Not much we can do over here. We have 3x plus 1 minus 1 over x. When you distribute 1 over x, it multiplies into all of these. And then plus ln x. Actually, we put the polynomial in front. So it's 6x plus 1 times ln x. There is really nothing we can, really factor here. It's just what it is. So f g prime g f prime. So that's the first half with the product rule. Second half is the quotient rule, which is when you have division of two functions, and we write the derivative is of f of x divided by g of x. So that's what we're looking for. So we have g of x squared, then we have g of x times f prime of x minus f of x times g prime of x. The formula is completely backwards from the product rule. The terms are swapped and there is a minus in between. If you want the alt, that's going to be the derivative of, let's just put primes everywhere. U over v prime is vu prime minus uv prime divided by v squared. We have about 10 minutes left, so we can do the examples in peace. So the derivative of 3x squared plus 6x minus 1 over x squared plus 1. Take the denominator and square it. I like to start there. Because as you can see, you have g of x and g of x squared, or v and v squared, right? So it's literally Control C, Control V, and square it. Copy it on top as well, x squared plus 1, times the derivative of the numerator, which is 6x plus 6, minus, copy the numerator, 3x squared plus 6x minus 1, times the derivative of the denominator is 2x. Now we multiply everything and add like terms. So we have 6x cubed plus 6x squared plus 6x plus 6. Now minus 6x cubed minus 12x squared and plus 2x divided by x squared plus 1. You don't ever have to deal with the denominator, because in chapter 4, when you set everything equal to 0, when you cross multiply, denominator will always cancel, so no one cares. Alright, 6x cubed and 6x cubed, that's gone. And the rest we can deal with. Let's go. 6 minus 12, that's negative 6x squared. Plus 8x. That was a good one. Plus 6 x squared plus 1 squared. You could kick out negative 2, but you don't really achieve anything with by kicking out negative 2, so we can just leave it here. So quotient rule, a bit messier than the product rule.
How much would you take off if you didn't simplify forward? say you get the setup part right, and then you get to your simplification part in your second step, and I don't know,
it doesn't matter, because you can't solve it in chapter 4. So you have to practice it now. It's completely irrelevant, because if on the exam 3 you lose 2 points out of 10, right? No harm done. Well, harm done, but no harm done, right? But in chapter 4, you can't solve the problem. You're losing technically 80% or 90% of the problem in chapter 4. It's the same problem, right? It's just in chapter 4 you have more stuff to do to the same thing, which is why factoring and simplifying is crucial for, to practice now, rather than, dealing with it in chapter 4 when you have to do everything else.
This homework is up right now.
This is going to be on the homework, yeah.
No, I'm just saying it's up in Canvas right now.
Homework? Not yet. It will be. I mean, I don't want to disappoint you guys. You got to enjoy these things, right? The derivative of 4x squared plus 6 divided by e to the 3x. Okay, so we take denominator and square it, which becomes e to the 6x. Then we put e to the 3x, copy, the derivative here is 8x, derivative of 6 is just 0, minus copy 4x squared plus 6 times the derivative of e to the 3x, which is 3e to the 3x. So now we see that we can pull out e to the 3x, and we have e to the 6x down there. So now I have 8x minus 12x squared, because 3 times 4 is 12, and then I have minus 18 inside as well. These guys will cancel, leaving e to the 3x behind, and we don't gain much by factoring out 6. We can factor out 6. We don't really gain much, so I'm just gonna leave it. Unless you are factoring x or something substantial, right? So negative 12x squared plus 8x minus 18 e to the 3x.
Where do you get 12x squared?
3 times there?
Mm-hmm.
Good. Now this problem can be transformed into what I call a boss way, right? What you can do is you can have your 4x squared plus 6 times e to the negative 3x. So in this case now you're working with the product rule, not with the quotient. So it's a really cool trick. So copy the first, 4x squared plus 6 times the derivative of the second, which is negative 3e to the negative 3x, plus copy the second e to the negative 3x times the derivative of the first, which is 8x. Now, when you multiply, you get negative 12x squared minus 18 e to the negative 3x plus 8x e to the negative 3x, and that negative 3x goes into the denominator, so negative 12x squared plus 8x minus 18 e to the positive 3x when you kick it down. And that's the same answer as you had before. So that's that. Cool. On Wednesday, we are going to do some very important stuff. Make sure you don't miss it. Bye.